Welcome to Factors that Affect Salvation. We're actually starting day 3, even though it says the end of day 3. You should have finished quiz 8.3. We will correct assignment 8.2. If you haven't already, we will do that and turn that in. Today's objective is that we calculate molarity of a given solution. We determine the concentration of Kool-Aid that is the most delicious, and we understand the factors that affect solvation. That is solvation, not salvation. We're also going to do the Kool-Aid lab on molarity. Please make sure as you finish that it gets cleaned up. So, an assignment 8.3 will be due next time. So let's talk about the relative rates of dissolution. There are certain factors that affect dissolution. One is grinding. Increasing the surface area will increase the rate that something dissolves. Stirring it, allowing the solvent to come into constant contact with the solid will help. And then heating, increasing kinetic energy, increasing the mixing. I call these my Kool-Aid rules because if you make hot Kool-Aid, then it will dissolve really fast. If you make it with powdered sugar, it will dissolve even faster. And if you stir it, it will dissolve even faster. However, if you try to make Kool-Aid with sugar cubes and ice cold water and don't stir it, you probably are not going to get good Kool-Aid. So the first one, grinding the solid. We want more surface area. So powdered sugar has the most surface area. Sugar cubes would have the least. Stirring or agitation. Stirring solution speeds up the rate because it disperses the solid and brings the solid into contact with all the solvent particles. So if I stir something, it tends to dissolve a lot faster than just letting it sit there and hope it dissolves. Heating the solution also increases the kinetic energy of the molecules in the substance, in the solvent, and because of that moves the water molecules around and causes them to be in more frequent contact with the solute. As we look at a solution, we go from unsaturated, meaning I can put more stuff into it, more stuff will dissolve, to saturated, meaning that's as much as I can dissolve in at that temperature. If I keep putting stuff in, it's just going to fall to the bottom. To what we call supersaturated. And what supersaturated is where we make candies and things like that, where we take sugar and we put a little bit of water and we heat it up and then we cool it down slowly and we make a solution that is supersaturated. It holds more than it should at that temperature. But if I add one crystal, then I end up with these crystals forming on or throughout it. So if a supersaturated solution, here's another look at it. We're actually going to watch a video. I'm going to have the person subbing stop the video at this time, and I'm going to have him show you this video that's up in the corner here about a supersaturated solution. When you finish watching the video, come on back. So at this time, you should have watched the video on the supersaturated solution, and it's pretty awesome. It would have fit right in here. This is the video, a picture of the video that you had watched. It is hot ice, which is sodium acetate, and you can actually make the sodium acetate by taking about a liter of vinegar and adding about 2 tablespoons of baking soda to it, and then heating it on the stove until it gets a nice little thin layer, and then putting it in a clean container, like they have flasks here, but you could use a cup, and letting it cool down to room temperature. And then you can pour it, and in the process of pouring is where you get the crystals forming. You can also put just a piece of crystal in to start with, and that starts solidifying, which is pretty cool. So another thing we can do is scratch the side or drop a crystal. When I have those kind of solutions, they are unstable. And supersaturated solutions are unstable. They crystallize with it by just adding a seed crystal or scratching the side of the flask, or if you ever use those reusable heat hot hand warmers where you click the little tin inside. So we're going to go to the Kool-Aid nub now. So what I would like to do is explain that to you again. I know I will have explained it to you the day before, but I want to explain it to you because I want my classroom clean and I want you to be able to do what you needed to. So you should have already passed off the pre-lab. If you haven't, you'll need to bring it up to the sub, and that sub has a key on the pre-lab and they will check that off. I don't want you weighing out ever more than 13 grams of any Kool-Aid. So let me just bring up another thing here that we can go through. Okay, so around the room, on a cart in the front, there is going to be some Kool-Aid. And you and the group behind you sitting at a table will have the same kind of Kool-Aid. So decide what it is. There'll also be scales around. So you're going to, everybody gets a cup, and you're going to mark on that cup with a permanent marker that's on the front table, one mark about 1 centimeter down. Okay, about. Just make sure that everybody in your group has about the same centimeter down. Okay, you're going to take and you're going to weigh this cup. So I'm putting it on a scale and I'm weighing the cup. You're going to have 3 trials that we figured out beforehand for your pre-lab. You're going to take and you're going to weigh out the first amount. And you're going to then in the cup add water to the line. You're going to take your little stir, coffee stir, everybody gets a coffee stir too, and you're going to stir it. And everybody together tastes it. And you're going to write in your lab what it looked like, what it smelled like, what it tasted like. 10 being the perfect Kool-Aid, 0 being not even close. Okay, then you're going to dump that out. You don't have to drink the whole thing if it's nasty. You don't have to drink the whole thing. You can dump it down my sink, but do not dump it anywhere in my garbage cans, just in the sink. Then you're going to weigh again the same cup, in the same cup. Everybody is doing their own cup. We're not sharing cups. In the same cup, you're going to weigh out what you figured out for number 2. So everybody gets their own cup. Okay, everybody gets their own cup. We're all trying number 2. Again, you're going to fill it with water to the line, stir it, taste it. Again, rate it. Do the same thing with 3. Now, at this point, you're going to decide between your group, that's the 2 that are in your lab partnership and the 2 that are behind you, what one you think is the best Kool-Aid. Maybe you think the best Kool-Aid is closest to 1. So then, for trials 4, 5, and 6, start with number 4 and say, okay, say that I weighed out 5 grams, and this is just a bogus amount for number 1. Say I weighed out 5 grams, but I thought it needed a little bit more, but not quite as much as 2. So maybe in number 4, I do 6 grams. And then you're going to figure out the molarity. So you're going to change that to moles. Then you're going to divide it by the 0.1 liters, and you'll get molarity of that one. Show me the work. Then make it. Then write down in the next table what you looked like, tasted like, smelled like, all that stuff. Again, fine tune it. Well, it was almost there, but not quite. So maybe 7 grams. Do that again. Find the moles, divide by 0.1 liters, find molarity. Again, make it, taste it. Oh, that was too much. So now I'm going to go back and maybe say 6.5 grams. Again, find the moles, divide it by 0.1 liters, find the molarity, taste it, and you're done. Make sure you clean up. Make sure that the Kool-Aid gets back up front. Make sure that everything on your desk is nice and tidy. I'll put some paper towels and cleaner out, so make sure your desk gets wiped down. And it's nice to have it wiped down anyway with everybody being sick. Once you're done with that, then you're going to do the post-lab. Make sure you do a conclusion. 3 sentences minimum. You need to be talking about the data, what things you wrote down, not this was a cool lab because we got to eat Kool-Aid or drink Kool-Aid, not that. I want to know, what do the data show you? How did you know to go more or less? And how did you know what would happen to the molarity? All that kind of stuff. When you're done, I want the room nice and tidy and clean. You're working on your next assignment, which, if we go back here, which is assignment number 8.3. Okay, so now is the time to get your stuff for your Kool-Aid lab, get it done before the end of the period, and work on assignment 8.3. Thanks.